Now I'd like to take a look at a regular log function and be able to categorize a bunch of those things that we did with exponential functions. Remember, we looked at exponential functions, we found things like domain, range, asymptotes, and intercepts. Those 6, again, will be very important for us to find for logarithmic functions. So if we have this log base 8 of 4 minus 7x, let's say this is our logarithmic function, we'd like to find each of these properties. So domain. If you remember, there was one rule that we had for domain of logs. That said that whatever was on the inside of my log, that had to be greater than 0. So I take the inside, 4 minus 7x, and I set that greater to 0. Then I solve this, so I subtract over 4, so I have negative 7x is larger than negative 4, divide by negative 7. Remember, when you divide by a negative, you switch the inequality, so x is going to be less than 4/7. So my domain then, in interval notation, if I'm less than 4/7, I'm negative infinity to 4/7. So that is the domain of my function, all real numbers less than 4/7. The range of the function, if you remember, the range, that was going to be all of these different y values, and we said that this was going to be negative infinity to infinity. So what we said back with exponential functions, remember, the domain of an exponential function is always negative infinity to infinity. Because of the inverse property that the inverse of an exponential function is a logarithmic function, and the domain and the range they switch, the domain of an exponential function is the range of a logarithmic function. So if the domain of an exponential function is all real numbers, the range of a logarithmic function is all real numbers. Okay. Now the vertical asymptote, if you remember how we saw these graphs, how they looked, was that we had wherever this was approaching, wherever this line was occurring, that the vertical asymptote was appearing based off of the domain. So we had an example that maybe looked like the following here. So notice the domain, if the domain's cutoff is 4/7, that is where a vertical asymptote will appear. And remember, the equation of a vertical line is x equals, so our vertical asymptote is x equals 4/7. So this number up here tells us the vertical asymptote. Horizontal asymptote, now if we think about the horizontal asymptote, well, we said this has none. Right? Especially if the range is all real numbers, I have to be able to get everywhere. All these y values have to be hit. If I had a horizontal asymptote, that would cut things off. So the horizontal asymptote is none. And again, remember, if we know exponential functions well, we said exponential functions, they had a horizontal asymptote. Then if we said that we're switching the x's and the y's when we take inverses, that if exponential functions have a horizontal asymptote, when we switch the x's and y's, that becomes a vertical asymptote. So that's why there is a vertical asymptote with logarithmic functions. Same way with an exponential function. An exponential function, it has no vertical asymptote. So an exponential function just kept going. So then if we switch the x's and y's, a logarithmic function will have no horizontal asymptote. So we can remember that again based off of exponential functions. Y and x-intercepts, here we set x equal to 0 for the y-intercept. So I plug in x equals 0. I have log base 8 of 4 minus 7 times 0. So this becomes log base 8 of 4. So this is my y value. This is y equals this. So this gives me the point, x equals 0, y is log base 8 of 4. Now, sometimes you will not have a y-intercept. What will happen Well, if this inside number is negative when you've simplified it, if you have a negative in there, there is no y-intercept. And that makes sense. In this example here, it never crosses the y-axis, so it's possible that we might have no y-intercept. But in this case, it does. So this is our y-intercept. Our x-intercept, now this is where we set y equal to 0. So now I have 0 is equal to log base 8 of 4 minus 7x. Now I'm trying to solve for x. Your go-to strategy at this point should be, can I convert it to exponential form? So if we think about converting this to exponential form, I have my base raised to the exponent. So I have 8 to the 0 is equal to this inside, 4 minus 7x. So that 8 to the 0 is just 1, and that is 4 minus 7x. I subtract over the 4. So I have negative 3 is equal to negative 7x. And so this becomes, after dividing by negative 7, I have 3/7 is equal to x. And again, remember, this is a point. The x-intercept will be the point 3/7, 0. So those are some of the operations I will be expecting you to be able to do on homeworks, on quizzes, and exams, to be able to show me that you understand these various rules and you're able to recognize where these different asymptotes are. And because they can connect to the exponential ones, the better you understand this and exponential ones, the better you can be able to relate those two in your mind.